Hi everybody, we're going to look at section 5.3 from the homework. There's only a few problems in 5.3, but they have a bunch of parts, and I only really need to look at one of the problems for you to see what they're all like. So I'm going to go ahead and jump in and look at the first question. Okay, so this one says that the GPAs for students at a prestigious university are normally distributed with a mean of 3.22 and a standard deviation of 0.19. Okay, I'm going to put that into my whiteboard here. The mean here is 3.22 and the standard deviation was 0.19. Okay. Given these facts, please answer the following questions. First, we want the probability that a randomly selected student from this university has a GPA less than 3.36. So this is written as P, the probability that X is less than 3.36. Okay, first we need to compute that, we need to find the z-score of 3.36, and it wants it to two places after the decimal. So our value of X here is the 3.36. Okay, and let's just go ahead and run that on our calculator. I'll get a fraction going. 3.36 minus the mean of 3.22 and then divide by the standard deviation of 0.19, like that. And again, they want two places after the decimal, so we're going to have to go with a 0.74 on this. So I'll put that in over here. Well, first let me put it on the board. 0.74, and then I'll put it into the answers, make sure it's right. So let me just check that. Should be okay. And looks good. So next we want to compute the probability. So it says to fill in the blanks and use table A1 to complete the problem below. Probability that X is less than 3.36 is the probability that Z is less than 0.74. So I can just put in the 0.74 here. Okay, and I think what I'll do now is go ahead and just draw this. So 0.74 is going to be positive, but to the right of 0. And we want the area to the left of this. So I'm just going to kind of roughly shade what I want here. Okay, just all this. Okay. And so the table that we need for it, again, is table A1. If we just look up the 0.74 here, let me go ahead and pop up that table. Again, we're just looking up the 0.74, so let me highlight this. So here's 0.7 and 0.04. And if we go in here, you can see our probability is 0.7704. That's the area to the left of my z-score, and of course I do want the area to the left. So the answer is just 0.7704. So we're going to slide back up here and just denote that here, that this is 0.7704. Okay, and so let me bring back my question and my calculator. I think that's all we needed for that. We'll just put in 0.7704 and check the answer. Should be okay, and it is. Okay, now we have another one coming up, so I'm just going to do a little cleanup work here. All right, so this one will be different. Let's see what it says. All right, so next we want a probability that a randomly selected student from this university has a GPA greater than 2.70. So this is written as P probability that x is greater than 2.70. So first we need the z-score of 2.70. So again, x is 2.70. I should not have erased the mean. The mean was 3.22. And the standard deviation, I think, was 0.19. Okay, so we'll do this computation real quick over here. Fraction 2.70, you could just do 2.7 on that. You don't need the 0 at the end. And minus 3.22. Uh-oh, I've got a little problem here, so let me go back. I notice I have two decimals. I'm just going to hit delete on one of them. Okay, and then go to the denominator. It's 0.19 down there. Like that, and enter. So, and they want two places, so I guess we're going to have to do negative 2.74. So I'll go ahead and put that on the left of 0 this time. Like that, and I think we can check this. So let's put in the negative 2.74, should be okay. Fingers crossed. And I will check it because I don't want to make mistakes from that. So let's just look real quick here. That one was okay right here. So the probability that x is bigger than 2.70 is the same as the probability that z is bigger than negative 2.74. Like that. And now we need to look that up. Let's just go ahead and again note we're doing a greater than problem, which means we're shading to the right on this. So I'm just going to again kind of roughly do this. Okay, and we're going to look up this negative 2.74 in table A1. But just note, table A1 only gives areas to the left. So as we slide down, we're going to look for 2.74. So negative 2.7 is here, and 0.04 is there. And so we just got to kind of line those up. And it looks like we're going to get a 0.0031 out of that. And then remind yourself again that this is the area to the left of negative 2.74. So I lost it. We have 2.74, 0.0031. Okay, so I only need to put in a 0.0031 as the area to the left here. Let me pinch and zoom out on that and go back. So I think what I said was 0.0031. That's the area to the left here. And that is not the area we want. So the rule of complements says if you want the opposite probability, then you have to do 1 minus the probability that you've got. So 1 minus 0.0031 will give the opposite side of the distribution. So we'll just do that real quick over here. 1 minus 0.0031 will give the area to the right. Again, the table only gives areas to the left, so that should be 0.9969. Like that. You can see all that. There we go. Trying to line it all up. Okay, so I think I can go ahead and put in the answer here as 0.9969. And then my fingers are crossed as I go ahead and check my answer. And everything's perfect. Amazing. Okay, now let's go ahead and do a little cleanup work here. Oh, sorry about that. So I'm going to erase a bunch of this stuff that I need to change. Okay, so this one says we want the probability that a randomly selected student from this university has a GPA between 3.03 and 3.70. So it's written as P probability that 3.03 is less than the student's GPA is less than 3.70. So that GPA is in between those. So we need the two z-scores, one for 3.03 and the other for 3.70. So I'm going to duplicate my formula for the z-score here. So I can do two z-scores. Okay, so the first one is 3.03. I'll put that up here. And the next one is 3.70. Okay, and then I'm going to clear my screen on the calculator. And start doing those computations. Okay, so first 3.03 minus 3.22, which is the mean, and then divide by the standard deviation of 0.19. Okay, and so that comes out amazingly as exactly -1. So unfortunately I forgot to erase these answers here. They are not -2.74. So I'll go ahead and put in a -1.00 for 3.03. And then I'll clear this. Actually, what I'm going to do is show you a little trick. If you highlight this expression, you can edit it after pressing enter. So I'm going to press the up arrow to highlight, and then one more to highlight, and then enter does a copy paste. Sometimes I just feel kind of lazy, so I'll navigate back into this expression and change this to a 3.70 like that, and enter. So here's my new z-score. Here I'm going to have to go with 2.53, I guess. So I'll put that down here as 2.53. Okay, and I want the area in between these. So I'm going from -1, which I'll put like right here, I guess, -1.00. And then the 2.53 is a little bit further out on the right side, 2.53. And this time I want the area between these, so I'll go ahead and highlight that. And then once again, we're reminding ourselves that the table only gives the area to the left, but it gives all the area to the left. I want some of the area to the left of 2.53 here, some of the area to the left, but I need to, so I'll look up the 2.53, but I'm going to have to subtract out the area to the left of -1. So I think I'll go ahead and start with the area to the left of 2.53 here. So let me go ahead and just do these one at a time. 2.53 is what we're looking at first. Okay, so, and I think I'll just write directly on this. 2.5 is right here, and 0.03 up there. So that probability is 0.9943. Okay, and I think I'll go ahead and somehow denote that. 9943 is the total area. So let's just kind of indicate everything from -2.53 all the way back. That total area was what? 9943. Okay, so I'm going to just put a little 0.9943 to remind me of that. And maybe I'll move this other formula out of my way a little bit. Just a little. Okay, and then the area to the left of -1 I need to subtract out. So let's go ahead and look that up. Just -1.00, that'll be on the negative side. Okay, so I guess I don't have to go all the way out there. So here's negative 1.0 and then plus the 0.00 here. So we're going to come all the way down. Little glitch, pardon that. Okay, so here's negative 1.00. So you get an area of 0.1587. So I'm going to go ahead and put that in. I think I'll just put it in under the tail, 0.1587. So what we need to do do this problem is this area here that I want, we're going to have to take everything to the left of 2.53. So that's all of this. Okay, I want to get rid of, take that total area, which is 0.9943. Okay, that whole area. And then I need to subtract out this 0.1587 area on the left. So I'll have to say minus 0.15, pardon me for that, just one sec. So minus 0.1587. Okay, so that is what I need to do. So real quickly, let me get back to my problems and my calculator. So on this, all that's left is to do 0.9943 minus 0.1587. And so in the end, we just remember whenever we want the area between two values, you have to look up both areas for the two z-scores. And then you just take the big area and subtract the small area, and that's what you always do on a problem like that. So this is coming out to 0.8356, which I'll go ahead and put. Wow, I haven't put anything over here, so let me go ahead and put all the numbers in on the homework. So for 3.03, the z-score was just -1. So I'll go ahead and put that in, -1. You can do 0.00 if you like. The calculator doesn't really see, or sorry, the computer doesn't really see trailing zeros very well, so it doesn't really matter if you put it in, but just for the look of it, I'll put it in. Then for 3.70, the z-score was 2.53. I think that looks good. So for x to be between 3.03 and 3.70, that's the same as z being between -1.00 and what was the other, 2.53. Okay, and then we did the math and came out to 0.8356 on the calculator. So 0.8356 is our answer. And once again, I will be checking it because I only have a little bit of faith. And it looks great. Okay, and now there's only one problem left. So I'm going to do a little cleanup work again. And I don't need the z-score formulas anymore, so those are going to go away. Oh boy. Half a moment, I'm having a little trouble. That's funny. Glitchy. Okay, so we're ready to start again with a new one. Still centered at 0. Looks like we're going to find a z-score and then convert it to someone's GPA. So it says, finally, we want to do a problem where we reverse the process. We want to know the GPA of a student who's in the 96th percentile. Okay, so the 96th percentile means that that student has a GPA higher than 96% of the rest of the school. Okay, and so what we need to do is figure out the z-score that goes with that, and then we'll convert it to a GPA. Okay, so first thing, we're going to go to table A1, And we're going to look for something approximately equal to 0.96. Okay, and so we'll go out to the edges of the table and see what's as close as possible to this 0.96 area. Okay, so let's go ahead and just slide down and see if we can find something close to a 0.96. So if you look at the table, what you'll see here is there is a couple of candidates. So there's a 0.9608, which is great, but it's not as close as another value. That's off by 8 in the 10,000th place. So that's no good. Let's go with the 9599. That's a little low, but only by 1 in the 10,000th place, so the 4th decimal place. So let's just go with the 9599. That's closer. And the z-score that goes with it, you can see, is 1.75. All right, so we'll slide back up here and use 1.75 for our z-score. Like that. And now, let me just put a 0.9599 is what we actually found in the table. And so that goes out to 1.7 and 0.05. Okay, so that's our z-score, 1.75. Okay, and then what we need to do is convert that to a GPA. So just remember, converting z to x, we have a formula for that. And the formula is x is mu plus z sigma. So you're just taking the mean and adding z standard deviations, which is what a z-score tells you information about. So the mean, if I go back, was 3.22. So we'll do 3.22 plus the z-score, which was 1.75, times the standard deviation, which I think was 0.19. So we're just going to run that on our calculator real quick. So again, whoops, can't see it, can you? Let me just pinch out on that a little bit so you can see. There we go. So 3.22 plus 1.75 times 0.19. Like that. And so that's 3.5525, and over here it wants the GPA. First of all, the z-score is what it asked for first. So let's give that z-score. It was 1.75. That's good. And then the GPA was it says 2 places after the decimal, so we'll do 3.55 here. And check our answer. And it looks like I got it right because I have 8 out of 8 on this. So that's the homework. Good luck with it.